Hello, in this lesson, we're going to talk about derivative as a function. Formally, we have the derivative definition of a function at point A. We have this definition, right? A is the point of interest, and we're looking for the derivative of the function at A. So this is the definition. So now imagine that we're interested in the derivative of a function at any point where the derivative exists. A, it will turn into an x. And if that limit exists, that will be the definition of a derivative at x. So anywhere the derivative exists, then we can have a formula. Now, what's the relationship between derivative and its function, right? So here, as you can see, we got two curves right here, okay? We got two curves, and one is the function, and one is its derivative. So the blue is the function, as you can see right here, and the red is the derivative. And for the function, you can see it goes down, goes up, plateau, and goes down. When the function goes down, you can see the blue, and then at the blue place, you can see if we draw the tangent line red is decreasing, it's decreasing line, and this curve itself is decreasing, and these indicates that the derivative is zero, is negative. It's negative. So you can see the red numbers are below x-axis. So these derivatives, right? The derivative for this particular point, the slope is -1, and the derivative value at this point is -1. And then you can see that the blue make a turn from decreasing to increasing. At this turning point, the slope is 0 because you can see it's a tangent line. And when slope is 0, the derivative of the function gives 0, which crosses the x-axis. And then it goes up, right? And these will be the positive slopes. Positive slopes of the tangent lines. So you draw, you're going to see that the derivatives are positive. And then it slows down. You can see the increase. This place increases up higher, faster. This in place a little bit slower, and then plateau. And you can see it's still positive because it's still increasing, right? But it slowed down a little bit until it hit the plateau and start to decrease. So here, that's why you see the negative derivative. So negative derivative indicates the curve is decreasing. Positive, the curve is increasing. When the derivative is 0, it means it's a turning point between decreasing to increasing or increasing to decreasing. All right, so let's use the formula to find derivative functions for a couple of functions here. I've chosen this function, okay? And we're going to apply the definition. The definition goes like this, okay? So we got f of x, and we need f of x plus h. So we're going to put it here, right? It's f of x plus h. So x will be replaced by x plus h. So everywhere, x will be replaced by x plus h. And here we go. And then we're going to plug in. Okay, we're going to plug in. And we got f of x plus h is this piece. Replace f of x plus h. F of x, of course, is this piece. So that is going to be replaced. I'm going to put a bracket about it. Okay. And next, we're going to open the bracket, right? The negative sign is distributed to x raised to the power 3 and negative x. So this is turning into plus x. Over here, we're going to open the parentheses, minus x minus h. How about x plus h to the power 3? If you know the formula, no, that's pretty good. If you don't know the formula, no problem. If you don't know the formula, you can work this out. I recommend on a scratch paper. Okay, don't work between the lines, right? So this is my scratch paper. I call it think out loud, but that's my scratch paper. So I don't remember the formula, so I'm going to just derive it. Okay. So I know the square, right? So you can do any way you want, really, here, as long as you get it 2hx, whatever, 2hx plus h squared. And then we're going to continue to do the FOIL. So x times x squared, that's x raised to the power 3. X times 2hx is 2hx squared. Okay? And x times h squared, that's x times h squared. And we're done with x times each one of these. Next, we're going to take h, multiply each one of that. So h times x squared, we got h x squared. Okay, so I line them up like this. I can do this on my scratch paper, right? It makes it easier. And h times 2hx. So this is going to be 2x h squared. And plus h to the power 3. Combine like terms. So we got x to the power 3. We'll keep it there. And combine these two, which are like terms, we get 3h x squared. And combine these two like terms, we got 3 times x h squared. And finally, h to the power 3. Okay? I suggest you do these work on a scratch paper instead of squeezing in between the lines. Okay, that usually causes a mess. Okay? Replace it. And then now we can continue to combine like terms. Okay? When you're showing your work, try not to put all those crosses in your work because it sometimes makes it harder to read your work. So do it on the scratch paper. Okay, do it on scratch paper. For example, I'll take all of these on scratch paper. The reason you want to write it down, you want people to be able to read it. Okay. So x raised to the power 3 takes away the x raised to the power negative of that, right? And negative x takes away the positive x. And what else can be combined? Right? I think we have these 4 terms left. So the next step, I would just have all of these left. Okay, feel free to double check and triple check. Okay, so 3x squared h plus 3x h squared plus h plus h to the power 3 minus h. We still cannot directly substitute, but we notice that every term has an h in the numerator. I'm going to factor out the h. Right, I'm going to factor out the h. And h is factored out. Oh, sorry, this is a square. And this h is out. So I'm factoring out the h. Right, so you can check if h times each one of them, you should be able to go back there. So this is purely algebra. And afterwards, h and h reduced. So this h will take away this h. And the whole of the limit part, the function being taken limit part, it just have this piece left. Now we can do direct substitution. Now we can do direct substitution, replacing h by 0. Replacing h by 0. So this will be replaced by 0, and this is replaced by 0. And what do we get in the end? We got 3x squared minus 1 in the end. So that's the derivative. We got our derivative function. Okay, so now, which part of work do you need to show to your reader? Just this much, okay? Just this much, really. Let me show you. I'm going to use this software to show you. All you have to just show in this much. You're done, okay? Or those other things, put it on the scratch paper, okay? Or put it on the side. It doesn't affect the viewing, okay? It doesn't affect the viewing, okay? Put it on this side. If you really want to show it, right, I recommend you pick up this space to show whatever you need to show, all right? Okay. Next, let's look at the picture. Let's look at the picture. Okay, the black curve is the function and the red is the derivative. Okay, so we have our function. Let me bring back the function. The function is x raised to the power 3 minus x. Right, that's the function. And its derivative we found is this piece. Okay, and we put these two graphs together. We know that derivative tells one is increasing or decreasing. You can see the red piece, this red piece is decreasing. Okay, is decreasing. And on derivative, it reflects them. Decreasing means that the derivative is going to be negative. So this piece is negative. Okay, this piece is negative. And it's decreasing gets, the decreasing gets, gets to be, there's a plateau point. Okay, there's a plateau. Actually, there's a negative 1/3. There's a negative 1/3. Because if you set it equal to 0, right, it's not really called for by this question. You don't really need to do that. If you set it equals to 0, what we get? We got x squared equals to 1/3. Okay, and then you take square root, right? You take square root, and you get square root of 1/3. Okay, I said 1/3. Actually, it's the square root of 1/3, right? So eventually, you get the 2 points where x equals to plus or minus the square root, right? It's because first you're going to get the absolute value of x, and that's going to be plus minus root 3 over 3. So, no, wait, we don't need this right now. So the next step, okay, the next step would be x equals to plus minus. I'll tell you what it means. Root 3 over 3. Okay, negative root 3 over 3 is where the derivative equals to 0. The red equals to 0 right here. Okay, and mark that point. Okay, root 3 negative, comma 0. So this point is where the derivative, right? The derivative is 0, and where it hits the plateau. You know, the curve hits the plateau right here. Okay, so it has that tangent line, horizontal, has that horizontal tangent line. Okay, so right here, something like that. Okay, that tangent line. So that point is on the curve is root 3 over negative root 3 over 3. So we have another point on this side, which is also similar. So we have 2 points, and the curve increases, right? The curve increases all the way here. You can see it increases slower, and the red is decreasing. The red are all positive, telling the curve is increasing. Okay, and from the highest point, it starts to go down. You can see the red becomes negative, because the curve, the black curve, is decreasing until it hit another plateau. And that point is root 3 over 3, comma 0. Okay, so let me mark that. There. Okay, the other point would be root 3 over 3, 0. So that point, right? So from here, the curve increases, and you can see the derivative becomes positive, and getting increases faster and faster. So that's about this example. Okay. All right. The second one, the second function, example number 2, is a very interesting one because the derivative of it is used. Okay, so we're going to find the derivative. So f prime, provided it's differentiable, right, equals to limit as h approaching 0. You can also see why we prefer this version of definition of derivative, right? So it's f of x plus h minus f of x and divided by h. Plug in all the way, right? So this will be square root of x plus h. We can remove the parentheses there, and f of x is root x. And here we go, right? We cannot do direct substitution, so we're going to do rationalization. Rationalizing the numerator. The technique is this technique we are very familiar. Conjugate, right? Divided by the same quantity, so we're multiplying by 1. Anything times 1 stay the same. So our next step, numerator times numerator. When numerator times numerator, we get a squared minus b squared. So this is going to be squared minus another piece squared, the b squared, denominator times denominator, and times at. Okay, so we can remove that piece. And next, we are going to, so this piece is going to be x plus h, and that's going to be x. And you are pretty familiar with this. You've probably done it many times over. So now we have only h left. So h and h reduced. So we have that, right? Now we can do direct substitution. Now we can do direct substitution. Remove the limit, substitute h by 0. So finally, we get to the derivative of square root of x, which is equals to 1 over 2 times root x. That's it. Okay, so we know the function. And we also know its derivative. So we graph these two functions in one rectangular system. That's what we get. The derivative, you can see the derivative, right? In terms of domain goes, the function, the domain is x greater than equals to 0. The derivative's domain, however, is x greater than 0. Okay, because it's in the denominator, it cannot be 0. It cannot be 0. So with that, as you can see, right, the derivative and the function itself is always non-negative, right? It's only at 0 is 0. It's always if it just goes up. It's just how fast it will, it's go up. So the derivative, the red, is always positive. It's above x-axis. Okay, it just it slows down. It slows down. The third example is a complex function. It's a rational function, and we're going to find its derivative. We're going to find its derivative. F prime equals to limit as h approaching 0 and f of x plus h, subtracting f of x divided by h. So, and of course, we should be aware of domain. Domain is x cannot be negative 2, right? Then we plug in, and we got f of x plus h. What is f of x plus h? Everywhere x will be replaced by x plus h. So this is replaced by x plus h, replaced by x plus h, replaced by x plus h. And so we're going to take that piece and replace f of x plus h, subtracting f of x. This is the reason why a lot of people don't like to deal with this, but you must, right? And you can. Okay, so we have this complex fraction. Okay, what do? We deal with it the way complex fraction is dealt with. Okay, so the common denominator is going to be 2 plus x multiply 2 plus x plus h. there. Boom. We take the numerator and make it equal denominator, so we're multiplying by 1. Okay. And then the next step is we're going to take this piece, we take the numerator to multiply the numerator, so we're going to multiply that piece and multiply that piece. Denominator times denominator. Okay, so that's the whole process. Okay, you can pause and do your own. Okay, so let's proceed. 2 plus x plus h reduced with this piece. 2 plus x replaces, reduced with 2 plus x. And what do we have left? Over here, you may like to write as minus x minus h, right? Minus x minus h. We need to be very careful. And we just have this piece left right there. And over here, you have 1 minus x over 1. So we just replace it. 1 minus x over 1, replace it with just 1 minus x in the parentheses. And what do we do next? What do we do next? Right? It's going to be a little bit tedious, but we must be careful and we must do it. You can strategically, to simplify it, okay, basically you just have to FOIL. The FOILing process, I wish you guys to know, I prefer that you work a lot of the things out on your scratch paper. Okay, so basically I'm taking this on my scratch paper. You still have to show something here, but I'm going to do this. All right, I still have everything. And this is the part I'm going to replace by after I work it out. Okay, after I work it out. Now, equals to 2 times 1, that's 2. 2 times negative x minus 2x. 2 times negative h is minus 2h. Okay, so 2 times all of these in the parentheses is done. And then I take the x, multiply everything inside the parentheses. So I'm going to plus x minus x squared minus hx. Okay, now look at that part. There's a negative sign in front of it. You know what? I'm going to bring this negative sign inside. So that would turn into x minus 1. Okay, so this way I would reduce. You can do what it was any way you want, but we should come up with the same answer. Okay, so I'm going to take x times all of these, right? Plus 2x plus x squared plus xh. And then I'm going to take a negative 1 to times each one of these. As I was multiplying, you know what? Okay, let's finish. Okay, so it's going to be minus 2 minus x minus 2 minus x minus h. Combining like terms. Now we're going to combine like terms. How am I going to combine like terms? I'm going to bring this x under negative under here, right? I got a 2x. I'm going to put it under here. Okay, so you can see we already simplify that. Minus x. So minus x here. There. Negative 2x, positive 2x makes 0, x, negative x makes 0. So all of these is going to make, they're going to be gone. Okay. Negative 2, positive 2 gone. hx, right? These two are opposites. X squared, gone. So we have a negative 3h left. Could that be true? Is that true? And you double check, okay? And that's what I got. Okay, of course I checked before I started the recording. All right. So on your scratch paper, you can do whatever you want, okay? And maybe do it again and again until you get it. Okay, I know this is pretty tedious, but it's algebra. You have to do algebra. You can't do algebra. You can't do calculus without algebra. So now we can do direct substitution. Okay, now we can do direct substitution by replacing h by 0. So in the end, we got this derivative. Basically, it's 2 plus x squared. Done. That's the derivative. We found it. Okay, so you just summarize it. Equals to, that's the derivative. Okay, we got some other examples, but I think on this one, I'm going to end here on this recording. Okay, so we have dealt with finding derivative for functions that are polynomial, root function, rational function. And that's all for this lesson. Thank you for watching.